Welcome to Ask and Learn.
Okay, so here we want, so a goal and want is to prove that a sub n minus k can be expressed in terms of a sub n, the backwards difference of a sub n, the backwards difference squared of a sub n, so on to the backwards difference to the k power of a n. Okay, so we're going to use induction. So let's let p of k be so this idea that a to the n minus k can be expressed as these backwards differences. Okay, so let's take the base case where k is equal to 1. Well, since the backwards difference of a sub n is equal to a sub n minus a sub n plus 1, then it follows that a sub n plus 1 is equal to a sub n minus the backwards difference of a sub n. Okay, so therefore, P1 is true. Okay, so that holds. So let's move to the induction step. So let pk be true. Then we need to show that p of k plus 1 is also true. Okay, so consider then a sub n minus, instead of k, it'll be k plus 1, which is equal to a sub n minus k minus 1. Okay, this is equal to a sub n minus 1 minus k. All right, and then since p of k is true, this is going to be equal to some function written as a of n minus 1, and the backwards difference of a n minus 1 all the way up to the backwards difference, the k power of a minus 1. Okay, then by definition of the first and second and k plus first differences, this can be rewritten as a sub n minus the backwards difference of a n, the backwards difference of a n minus the backwards difference squared of a n, all the way up to the backwards difference to the k of a n minus the backwards difference k plus 1 a n. Okay, so therefore, P of k plus 1 is also true. And so by the principle of mathematic induction, I sort of ran out of space on that previous page. But so by induction, then we know that Pn must be true for all positive integers n. So n is a positive integer. Okay, and that concludes the proof.